According to the Central Statistics Office, CSO, there were 65,909 babies born in Ireland in 2015. Of these, 32,290 were girls. In the first part of the question, we must find how many boys were born in Ireland in 2015. The key observation here is that together, the boy babies and the girl babies will combine to give us the total number of babies. Another way to view this is that the boy babies will be equal to the total babies minus the girl babies. The total number of babies is 65,909. The number of girl babies was 32,290. To find the number of boy babies, we must subtract these numbers away. So our answer here is that there were 33,619 boy babies. In the next part of the question, we must find the probability that a baby picked at random from those born in Ireland in 2015 is a boy. And we must give our answer correct to 2 decimal places. A useful fact to keep in mind is the following. Assuming equally likely outcomes, the probability of an event is the number of desirable outcomes divided by the total number of outcomes. We're asked for the probability of picking a boy baby. So in this context, the number of desirable outcomes refers to the number of boy babies. The total number of outcomes refers to the total number of babies. So to find our probability, all we have to do is divide these 2 numbers. Rounded to 2 decimal places, the probability of selecting a boy baby is 0.51. Eight babies were born in Limerick's maternity hospital on the 1st of May 2015. Use your answer in part A, II, to find the probability that the first 3 babies born were boys. Give your answer correct to 4 decimal places. It's difficult to reason about all 3 babies at the same time, so let's break things down one by one. The first baby, the second baby, and the third baby. We need the first 3 babies all to be boys. The only way this can happen is if the first baby is a boy, and the second baby is a boy, and the third baby is a boy. In probability, when we see the word "and", it indicates that we should multiply the individual conditional probabilities. So once we find the probability of each of our individual events, all we have to do is multiply them all together. Well, in part A, II, we found that the probability that a randomly selected baby is a boy is 0.51. so the probability that the first baby is a boy is 0.51. Similarly, the probability that the second baby is a boy and the probability that the third baby is a boy are both 0.51 as well. Now that we have the individual probabilities, we must multiply them together. Rounded to 4 decimal places, the probability that the first 3 babies born were boys is 0.1327. The next part of the question reads, find the probability that the third birth was the first girl born in the hospital that day. Give your answer correct to 4 decimal places. Again, a good strategy here is to break things up baby by baby. We want the third birth to be the first girl. This means that the first baby is not a girl, the second baby is not a girl, and the third baby is a girl. In other words, we need the first baby to be a boy, and the second baby to be a boy, and the third baby to be a girl. Similar to above, when we see the word "and", it indicates that we should multiply together the individual probabilities. We know that the probability of randomly selected baby is a boy is 0.51. So, the probability the first baby is a boy is 0.51, and the probability the second baby is a boy is 0.51 also. The probability that the third baby is a girl is a little less clear, so we'll have to do some work to figure this out. The following probability fact will help us here. If you consider all the possibilities, the probabilities must add up to 100%, or 1 in decimal form. In this question, we've been using decimal form for our probabilities. Using this fact, we know that the probability of getting a boy baby and the probability of getting a girl baby must combine to add up to 1. Another way to think of this is that the probability of a girl baby will be 1 minus the probability of a boy baby. And we know the probability of a boy baby. It's 0.51. And when we do the calculation, 1 minus 0.51, we get 0.49. So this is our probability of getting a girl baby. We've now written in all our individual probabilities. From here, all we have to do is multiply them together. Rounded to 4 decimal places, our final answer here is 0.1274. The table below shows the probability of being born on a particular day of the week. Complete the table. We are provided with the probabilities of being born on a Monday, Wednesday, Thursday, Friday, Saturday, or Sunday. The only thing that's missing here is the probability of being born on a Tuesday. To make our lives a bit easier down the road, I'm going to label this unknown value with x. Well, the key fact to remember here is that if you consider all the possibilities, the probabilities must add up to 100%, or they must add up to 1 if you're working in decimal form. In our table, we've listed all 7 days of the week, so we are covering all the possibilities for the day that you could be born. This means that if we add up all the probabilities, we must get 1. From here, we can solve for x. A good first step would be to do some simplification on the left-hand side by adding up all those numbers. So we know that x plus 0.84 is equal to 1. To find x, all we have to do is remove this plus 0.84. This represents addition, and the inverse of addition is subtraction. So to remove it, we will subtract 0.84 from both sides. So we found that the probability of being born on a Tuesday is 0.16. Part II. In a particular week, 1,300 babies were born. Find the number of babies expected to be born on the Tuesday of that week. The key to solving this question is the following observation. The expected Tuesday babies is equal to the total babies born in the week multiplied by the probability an individual baby is born on a Tuesday. In this question, we're told that 1,300 babies were born in the week. In the previous part of the question, we found that there was a 0.16 probability of being born on a Tuesday. To get our answer, we multiply these numbers together. So our final answer is that the expected number of Tuesday babies is 208. The circle C has centre 0, 0 and radius 5 units. Write down the equation of C. This question involves the equation of a circle. So the first thing to do is to open up our formula book to page 19 and look at the formula for this. It states that the equation of a circle with centre hk and radius r is x minus h all squared plus y minus k all squared is equal to r squared. Here, h and k refer to the coordinates of the centre. Our circle has centre 0, 0. So h is equal to 0 and k is equal to 0. R refers to the radius, and in our question, the radius is 5 units. So r is equal to 5. From here, all we have to do is to sub these values into our formula. Here we can simplify a bit. X minus 0 is just x, y minus 0 is just y, and 5 squared is equal to 25. So our final answer here is x squared plus y squared is equal to 25. Part B. The diagram shows a semicircle which is part of C. The point P is equal to minus 4k, where k is greater than 0, is on the semicircle. Find the value of k. So we're told that this point P is on the circle. There's a helpful fact which will allow us to use this information. A point, xy, is on our circle if and only if it satisfies the equation of the circle. We know that the point P is equal to minus 4k is on the circle. Since P has an x coordinate of minus 4 and a y coordinate of k, x equals minus 4 and y equals k must satisfy the equation of the circle. So what we'll do is we'll take the equation we found in part A and sub in x is equal to minus 4 and y is equal to k. So we found that 16 plus k squared is equal to 25. Our goal here is to find the value of k. In other words, to isolate it all by itself on one side of the equation. To do this, we'll need to remove the 16 and the square. Let's start by removing the 16. This 16 represents addition. The inverse of addition is subtraction, so to remove plus 16, we should subtract 16 from both sides. Now, we'll need to remove the square. The inverse of a square is a square root, so here we should square root both sides of the equation. We have to be careful when we have equations involving squares. If we type the square root of 9 into our calculator, we'll get the answer plus 3. However, the negative version of this, minus 3, also squares to 9. So here we'll have two possible answers. K is equal to plus 3 and k is equal to minus 3. Though in this question, we're told that k must be greater than 0. So this rules out the minus 3. So our final answer here is that k is equal to 3. Part II. Show that the triangle ABP is right angled at P. To help us visualize this, let's draw in the lines from A to P and P to B. There's a useful fact which will help us here. An angle which stands on a diameter of a circle is always equal to 90 degrees. In other words, it's a right angle. In our picture, AB is a diameter of the circle. The angle at P is standing on this diameter. Our fact tells us that any angle standing on a diameter must be a right angle. Hence, the angle at P is a right angle. Part C. Find the area of the region which is inside the semicircle but outside the triangle ABP. Give your answer in square units, correct to 2 decimal places. The region inside the semicircle but outside the triangle corresponds to this red region in the diagram. It's quite difficult to find the area of this region directly. However, we could find it as follows. We can start with the full area of the semicircle and then subtract away the area of the triangle. So once we calculate these 2 areas, we'll be able to find our answer. Let's start with the area of the semicircle. We were told at the top of the question that our circle has a radius of 5. There's a result in the formula book on page 8 for the area of a circle. It says that a circle with radius r has area A given by A is equal to pi r squared. In our scenario, we have a radius of 5. So to find the area of the full circle, we should sub in r is equal to 5. So the area of the full circle is 78.5398. However, we don't have a full circle. We have a semicircle. Well, a semicircle is half of a circle, so it will have half of the area. So to find the area of the semicircle, we find a half of the number we just found. Now, let's turn our attention to the area of the triangle. There's a formula on page 9 of the formula book for calculating the area of a triangle. It says that a triangle with a base of A and a perpendicular height of h has area, capital A, given by capital A is equal to a half times little a times h. To use this formula, we'll need to identify the base A and the perpendicular height h. In our triangle, the base runs flat straight along the x-axis, and it goes from an x value of -5 to an x value of +5. This is a distance of 10 units. So our base A is equal to 10. To find our perpendicular height, we should look at the height of our point P. In a previous part of the question, we found that k is equal to 3. This means that P has a y-coordinate of 3. In other words, its height is 3. So the perpendicular height of our triangle, H, is equal to 3. Now that we know the base and the perpendicular height, we can sub into our formula for the area of a triangle. So, we found that the area of the semicircle was 39.2699 and the area of the triangle was 15. As we noted at the beginning, to get our answer, all we have to do is subtract away these two areas. Rounded to 2 decimal places, our final answer is 24.27 square units. Question 3a. The points A is equal to 2, 1, B is equal to 6, 3, C is equal to 5, 5, and D is equal to 1, 3 are the vertices of the rectangle ABCD as shown. In part I, we're asked to show that the length of the line AD is equal to the square root of 5 units. There's a formula on page 18 of our formula book which allows us to calculate the length of a line segment. It says that given 2 points, P is equal to x1, y1, and Q is equal to x2, y2, the length of the line segment PQ is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We want to find the length of the line segment from A to D. So these are the 2 points of interest. A is equal to 2, 1, and D is equal to 1, 3. To use our formula, we should label the first point as x1, y1, and the second point as x2, y2. From here, it's a matter of subbing into the formula and doing some calculator work. So we found that the length of the line AD is square root of 5 units. And this is precisely what we needed to show. Part II. Find, in square units, the area of the rectangle ABCD. Well, to find the area of a rectangle, we multiply the length times the width. Looking at a rectangle, I'm going to label the side AD as the width and the side AB as the length. In the previous part of the question, we found that the length of the line AD is the square root of 5. So we already know the width. However, we don't know the length. To find this, we'll need to calculate the length of the line segment AB. Just like the previous part of the question, we can find this by using the length of a line segment formula. Here, we want the length of the line from A to B. So the 2 points of interest are A is equal to 2, 1, and B is equal to 6, 3. To use our formula, we're going to label the first point x1, y1, and the second point x2, y2. From here, we'll sub in the values into our formula and do some calculator work. So we found that the length of the line segment from A to B is the square root of 20. In other words, the length of a rectangle is square root of 20. Now that we know the length and the width, to find the area of the rectangle, all we have to do is multiply these two numbers together. So our final answer here is that the area of the rectangle is 10 square units. Part B. Find the equation of the line BC. Give your answer in the form ax plus by plus c is equal to 0, where a, b, and c are elements of the integers. We are asked to find the equation of a line. On page 18 of the formula book, there's a result which will help us. It says that the equation of the line which passes through the point x1, y1 and has slope m is y minus y1 is equal to m times x minus x1. To use this formula, we need to know two things: a point on the line and the slope of the line. We want the equation of the line BC. In other words, the line that passes through the points B and C. So we actually know 2 points on our line. B is equal to 6, 3, and C is equal to 5, 5. Either of these will do when it comes to the point in our equation of a line formula. The other thing we need is the slope, and unfortunately we don't know this. However, we can calculate it. There's another useful formula on page 18 of our formula book which will allow us to find the slope of a line. It says that the slope m of the line passing through the points x1, y1 and x2, y2 is m is equal to y2 minus y1 over x2 minus x1. We have already identified 2 points on our line, B and C. To use our slope formula, we should label the first point with x1, y1, and label the second point with x2, y2. From here, we can sub into our slope formula. So we found that our slope, m, is minus 2. Now that we have a point and the slope, we're ready to use the equation of a line formula. Here, I'll use B as my point. So x1 is 6 and y1 is 3. The slope m is the minus 2 we just found. So let's sub these values in. From here, I can do some simplification by multiplying out the brackets on the right hand side. Minus 2 times x is minus 2x. And minus 2 times minus 6 is plus 12. We are asked to present our answer in the form ax plus by plus c is equal to 0. In other words, we'll want all our terms to be on the left-hand side of the equation and a 0 on the right. So here, I'll need to remove the minus 2x and the plus 12 from the right-hand side of the equation. Let's start with the minus 2x. Because of the minus sign, this represents subtraction. The inverse of subtraction is addition, so to remove a minus 2x, I should add 2x to both sides of my equation. Now, let's remove the 12 from the right-hand side. This represents addition, and the inverse of addition is subtraction. So to remove a plus 12, I should subtract 12 from both sides. From here, we can do some simplification. Minus 3 minus 12 is minus 15. We were asked to give our answer in the form ax plus by plus c is equal to 0. Here, the x term came first, the y term second, and the number term third. So to finish everything off, we should reorder things into this format. Our final answer for the equation of the line BC is 2x plus y minus 15 is equal to 0. Part C. Use trigonometry to find the measure of the angle ABD. Give your answer correct to the nearest degree. To find the angle ABD, it will be helpful to think about the triangle ABD. To visualize this, we should draw in the line joining D to B. The angle we're after is ABD. I'm going to label this with theta. In the previous parts of this question, we found out some useful information about this triangle ABD. We saw that the length of AD was the square root of 5, and the length of AB was the square root of 20. So, how can we use this to find the angle theta? Well, our triangle ADB is a right-angled triangle. And when we want to find an unknown angle in a right-angled triangle, we can use SOHCAHTOA. This result says that the sine of theta is equal to the opposite over the hypotenuse, the cosine of theta is equal to the adjacent over the hypotenuse, and tan of theta is equal to the opposite over the adjacent. In a right-angle triangle, the hypotenuse refers to the side opposite the right angle. In our triangle, this is the side BD, and we don't know the length of this side. The opposite is the side opposite our angle theta. In our triangle, this is the side AD, and we know that this has a length of root 5. The adjacent is the side which touches our angle theta, which is not the hypotenuse. In our triangle, this is the side AB, and we know that this has a length of root 20. We know the opposite and the adjacent, so we should look through sine, cos and tan and see which one uses both of these. Here we see that tan of theta is equal to the opposite over the adjacent. In our triangle, we have an opposite of root 5 and an adjacent of root 20. So let's sub these in. Our goal here is to find the value of the angle theta. To do this, we'll need to remove the tan in front of it. Whenever we want to remove something from an equation, we need to perform the inverse operation to both sides. There's a function called tan inverse, which is defined to be the inverse of tan. So here, we should take tan inverse of both sides. From here, it's a matter of doing some calculator work and some rounding. Our final answer is that the angle ABD is equal to 27 degrees. Question 4. A. Construct the triangle ABC where the length of AB is 8 centimeters, the length of AC is 5 centimeters, and the length of BC is 7 centimeters. Let's start by drawing in the side AB. We know that this side should be 8 centimeters long. For this, we simply get out our ruler and draw a line 8 centimeters long, labelling the endpoints A and B. We need the length of AC to be 5 centimeters. The next step is to set our compass to 5 centimeters, put the point at A, and to draw out a little arc. We need the length of BC to be 7 centimeters. So our third step is to set our compass to 7 centimeters, put the point at B, and draw an arc. The point where these two arcs meet is C. Using our ruler, we join this point to A and we join it to B. And this completes our triangle. Part B. The diagram shows a square of side length 2k centimeters. Write down, in terms of k, an expression for the area of the square. Finding the area of a square is quite simple. All we have to do is take the side length and square it. In our square, the side length is equal to 2k. So our area will be 2k all squared. Inside our brackets, we have a 2 and a k, and all of this is being raised to a power of 2. When you have multiple things being raised to a power, each one gets a copy of the power. So here, the 2 gets a copy of the square, and the k gets a copy of the square. So 2k all squared is equal to 2 squared times k squared. And here we can simplify. 2 squared is equal to 4. This gives us our final answer. The area of the square is equal to 4k squared. An isosceles triangle with side lengths of 20 centimeters and hypotenuse of length 2k centimeters is removed from the square, as shown. Find the value of k, correct to 2 decimal places, and the area of the remaining shaded section. To begin, let's focus in on this white triangle. We've 2 side lengths of 20 and a side length of 2k. An important observation here is that the white triangle is a right-angled triangle. This is because the 4 corners in a square are all right angles. Well, we've a right-angled triangle and we're concerned with the 3 sides. In this situation, we can use Pythagoras' theorem. This can be found on page 16 of the formula book. It states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. In the statement of the theorem, the hypotenuse is labelled as C and the other 2 sides are labelled as A and B. Well, the hypotenuse is the side which is opposite the right angle. In our triangle, the side opposite the right angle has length 2k, so we'll let C be equal to 2k. The other 2 sides can be labelled as A and B, and it doesn't matter what order we do them in. Here, A will be 20, and B will be 20. Now that we know A, B and C, let's sub in to Pythagoras' theorem. Our goal here is to find the value of k. To start, let's do some simplification. We can get out our calculator and type in 20 squared plus 20 squared and we'll get 800. 2k all squared is equal to 2 squared times k squared, which is equal to 4k squared. This is similar to the calculation we did in the previous part of the question. Remember, our goal here is to solve for k. In other words, to isolate k all by itself on one side of the equation. To do this, I'll need to remove the 4 in front of the k and the 2 in the power of the k. Let's start by removing the 4. This 4 is being multiplied by the k squared. The inverse of multiplication is division, so to remove multiplication by 4, I'll divide both sides by 4. Now, I'll need to remove the square. The inverse of a square is a square root. So to remove a square, I should square root both sides of the equation. So our answer for this part of the question is that k is equal to 14.14 centimetres. As well as finding k, we are asked to find the area of the remaining shaded section. Well, looking at our picture, the shaded section is what we get when we start with the square and remove the white triangle. So the area of the shaded section will be the area of the full square minus the area of the white triangle. So the strategy here will be to find the area of the square and find the area of the white triangle and then subtract them away. In the previous part of the question, we found an expression for the area of the square. The area of the square was equal to 4k squared. Well, we've now found k, it's 14.14, so if we sub this in, we can find the area of our square. When it comes to the area of the white triangle, there's a formula on page 9 of the formula book which will help us. It says that a triangle with a base of A and a perpendicular height of H has area capital A equal to a half times A times H. The white triangle has a base of 20, so A is equal to 20. It has a perpendicular height of 20, so H is equal to 20. We can find our area by subbing these values into the formula. Now that we know the area of the square and the area of the white triangle, we can find the area of the shaded region by subtracting these two numbers away. Our final answer here is that the area of the shaded region is 599.7584 centimeters squared. Question 5. In a survey, the IQ scores of 1,200 people were recorded. The mean score was 100 points and the standard deviation was 15 points. Assuming that IQ scores are normally distributed, the data are shown on the diagram. Firstly, we must fill in the missing numbers on the horizontal axis. We are told that the data is normally distributed. When it comes to normal distributions, there's some conventions with the labelling. The middle mark is labelled with the mean, and the standard deviation gives the jump between marks. We are told that the mean score was 100 points. So the middle mark should be labelled with 100. In our diagram, we were given the label of the mark before the middle one. It's 85. To get from 85 to 100, we must add 15. So the jump between marks is plus 15. It's not a coincidence that our standard deviation is also equal to 15. As mentioned earlier, it's conventional that the standard deviation gives a jump between marks. Now that we know the jump is 15, we can fill in the remaining labels. 100 plus 15 is 115. 115 plus 15 is 130. And 130 plus 15 is 145. On the other side, 85 minus 15 is 70. And 70 minus 15 is 55. Part II. A person is chosen at random from those surveyed. Use the empirical rule to find the probability that this person has an IQ score between 70 and 130 points. We are asked to use the empirical rule, so let's remind ourselves of what this is. It states that 68% of the data is within one standard deviation of the mean, 95% of the data is within 2 standard deviations of the mean, and 99.7% of the data is within 3 standard deviations of the mean. In our question, we are interested in IQ scores between 70 and 130. Remember, our mean is 100 and our standard deviation is 15. 70 is 2 standard deviations to the left of the mean. 130 is 2 standard deviations to the right of the mean. So 70 to 130 corresponds to the region of data which is within 2 standard deviations of the mean. From our empirical rule, we know that 95% of the data lies in this interval. So our answer here is 95%. Part III. Use the empirical rule to find the approximate number of people surveyed with an IQ score of between 85 and 115 points. An IQ score between 85 and 115 corresponds to the shaded region in our diagram. Our mean is 100 and our standard deviation is 15. 85 is 1 standard deviation to the left of the mean, and 115 is 1 standard deviation to the right of the mean. So the region of interest corresponds to the data which is within 1 standard deviation of the mean. Using our empirical rule, we know that there's a 68% chance that a person falls in this range. So, each individual person we surveyed has a 68% chance to have an IQ score between 85 and 115. We surveyed 1,200 people. And of these people surveyed, we'd expect 68% of them to have an IQ score between 85 and 115. To find the expected number of people, all we have to do is multiply 1,200 by 68%. Some calculators can struggle with the percentage symbol, so it will be useful to convert the 68% to a decimal. To do this, all we have to do is divide by 100. So 68% is equal to 0.68 as a decimal. Using our calculator, we see that 1,200 times 0.68 is equal to 816. So our final answer here is that we expect 816 people to have an IQ score between 85 and 115. Part B. A class of 24 pupils is made up of 10 boys and 14 girls. Chemistry is studied by 6 of the boys and 9 of the girls. A pupil is chosen at random from the class. Find the probability that the pupil chosen is a boy or is a pupil who does not study chemistry. Given a student in this class, there's 2 questions we're concerned with. Firstly, is the student a boy or a girl? And secondly, do they study chemistry or do they not study chemistry? It will be useful to draw a table and split up the students based on these 2 questions. We are told that chemistry is studied by 6 of the boys. So in the intersection of boys and study chemistry, I'll write a 6. We know that chemistry is studied by 9 of the girls. So in the intersection of girls and study chemistry, I'll write a 9. Now, we're told that there are 10 boys in the class. We know that 6 study chemistry, so the remaining 4 must not study chemistry. So I'll write a 4 in the intersection of boys and do not study chemistry. We know that there's 14 girls in the class and 9 of them study chemistry. The remaining 5 must not study chemistry. So I'll write a 5 in the intersection of girls and do not study chemistry. We need to find the probability that a randomly chosen pupil is a boy or does not study chemistry. Well, we can use our table to count up how many students are in this category. We'll want to include everyone who is a boy and also everyone who does not study chemistry. In total, we have 6 plus 4 plus 5 is equal to 15 students who are boys or do not study chemistry. We know that the class has 24 pupils in total. 15 of these are boys or do not study chemistry, so the probability we select one of these is 15 out of 24, which written as a fraction is 15 over 24. Question 6. A. Find the distance x in the diagram which is not drawn to scale. Give your answer correct to 2 decimal places. So let's have a look at the triangle we're given. We know 2 of the angles, 65 degrees and 63 degrees. One of the sides is labelled as being 10 centimetres long, and another of the sides is labelled as x. This is what we must find. There's a useful fact about triangles, which says that the 3 angles in a triangle must always add up to 180 degrees. This means that whenever you have 2 angles in a triangle, it's quite easy to find the 3rd angle. It's simply the leftovers needed to make sure all the angles add to 180. Here, 65 plus 63 is 128. The 3rd angle is the leftovers needed to make this sum into 180. To find it, we can do 180 minus 128, which is 52. Even though we weren't asked to find this angle directly, the more information we know about the triangle, the easier it's going to be to find x. So, let's focus on finding x. Our triangle is not right-angled. In this situation, there's two main options for finding unknowns: the sine rule or the cosine rule. To determine which of these to use, it's helpful to think about the number of sides and the number of angles that we are concerned with. The sine rule involves two sides and two angles. The cosine rule involves three sides and one angle. Notably, the cosine rule involves all three sides. In our triangle, we only have two sides labelled. This rules out the cosine rule, so here we'll want to use the sine rule. This rule can be found on page 16 of the formula book. It says that given any two side plus angle pairs, little a capital A and little b capital B, we will have little a over sine of capital A equals little b over sine of capital B. The convention here is that we use capital letters to denote angles and the lowercase equivalent for the side opposite that angle. So here, capital A is an angle and lowercase a is the side opposite that angle. Capital B is a different angle and lowercase b is the side opposite that angle. So let's look at the triangle we were given. The key to using the sine rule is thinking about pairs of an angle and the side opposite it. To use our sine rule, we need two of these pairs. For the first pair, we can take the 63-degree angle and the 10cm side opposite this angle. I'll label these with capital A and lowercase a. For the second side angle pair, I'll take the 52-degree angle and the side labelled x opposite this. I'll label the angle with capital B and the side with lowercase b. We are now ready to sub in to the sine rule. Our goal here is to solve for x. In other words, to isolate x all by itself on one side of the equation. To do this, we'll need to remove the sine 52. A fraction represents division. X over sine of 52 is the same thing as x divided by sine of 52. The inverse of division is multiplication, so to remove division of sine 52, I should multiply both sides by sine 52. From here, it's a matter of doing some calculator work and some rounding. Rounded to 2 decimal places, we found that x is equal to 8.84. X represents a side length, and the unit here is centimetres. So our final answer is that x is equal to 8.84 centimetres. Part B. Find the distance y in the diagram, which is not drawn to scale. Give your answer correct to 2 decimal places. In the triangle we're given, one of the angles is labelled as 53.8 degrees. One side is labelled as 10.2 centimetres, another side is labelled as 8.5 centimetres, and the final side is labelled as y. Similar to part A, this is not a right angle triangle. And there's 2 main options for finding unknowns in this situation: the sine rule or the cosine rule. To determine which of these to use, it's useful to think about the number of sides and the number of angles involved. The sine rule involves 2 sides and 2 angles. The cosine rule involves 3 sides and 1 angle. If we look at the labels on our triangle, we have labels on all 3 sides and on 1 angle. So here, using the cosine rule will be a good idea. This rule can be found on page 16 of the formula book. It says that given 3 sides, A, B, C, and the angle capital A squared is equal to B squared plus C squared minus 2BC times the cosine of capital A. As before, the labelling convention is to use capital letters for angles and the lowercase equivalent for the side opposite that angle. When using the cosine rule, it's crucial that the side labelled with a lowercase a is opposite the angle labelled with capital A. The labellings of B and C are less important. They play symmetric roles and can be assigned to the other 2 sides in either order. The cosine rule only involves 1 angle, capital A. In our triangle, we only know 1 angle, this 53.8 degrees. So let's label this with capital A. The side opposite this gets labelled with lowercase a. In our triangle, this is the unknown value y. The other 2 sides can be labelled with B and C in any order. Here, I will let B be 10.2 and C be 8.5. From here, we can sub in to our cosine rule. The right-hand side here is quite messy, but we can simplify things a lot just by using our calculator. We found that y squared is equal to 73.879. To find what y is, we'll need to remove the square. The inverse of a square is a square root, so to remove a square, we should take the square root of both sides. From here, it's a matter of doing some calculator work and some rounding. Rounded to 2 decimal places, we found that y is equal to 8.60. Here, y represents a side length, and the unit here is centimetres. So our final answer is that y is equal to 8.60 centimetres. Question 7. Cones is a sculpture in the National Gallery of Australia. It consists of 14 identical steel cones, arranged into pairs which are joined together as shown. The height of each cone is equal to the diameter of its base. If the radius of the base is 2.25 meters, write the height of a cone. Well, we're told that the height is equal to the diameter. The diameter of a circle is 2 times the radius of the circle. We're told that the radius is 2.25 meters. So let's sub that in for the radius. And the calculation here, 2 times 2.25 comes out as 4.5. Our unit here is meters, so our final answer is that the height is 4.5 meters. Part II. Show that, correct to 2 decimal places, the slant height, L, of a cone is 5.03 meters. The following fact will be quite helpful. If a cone has a radius of r, a height of h, and a slant height of L, then L squared is equal to r squared plus h squared. This is a good fact to know, but if you didn't know it, it could be derived on the spot by using Pythagoras' theorem. From part I of the question, we know that our cone has a radius, r, of 2.25 meters and a height, h, of 4.5 meters. Let's sub these into our result. From here, we can simplify the right-hand side by doing some calculator work. We found that L squared is equal to 25.3125. To find L, we'll need to remove the square. The inverse of a square is a square root, so to remove a square, we should take the square root of both sides of the equation. From here, it's a matter of doing some calculator work and some rounding. Rounded to 2 decimal places, L is equal to 5.03. L represents the slant height, and the unit here is meters. So our final answer is that the slant height is 5.03 meters. This is exactly what we were asked to show. Part B. In order to maintain the steel's reflective shine, the surface is polished regularly. Find the curved surface area of the entire sculpture, 14 cones. Give your answer correct to 2 decimal places. The shape we're concerned with here is a cone, and we are asked about the curved surface area. There's a result on page 10 of the formula book which will help us here. It says that the curved surface area, A, of a cone with radius r and slant height L is A is equal to pi r L. From the previous parts of the question, we know that each individual cone has a radius r of 2.25 meters and a slant height L of 5.03 meters. To find the curved surface area of one cone, we sub these values into our formula. A is equal to pi r L. So we found that the curved surface area of one cone is 35.5550. However, the sculpture isn't just one cone, it consists of 14 cones. To find the curved surface area for 14 cones, all we have to do is multiply this number by 14. This gives an answer of 497.77. The distances in this question were measured in meters, and for an area we always need to use squared units. So our unit here is meters squared. This means that our final answer is 497.77 meters squared. Part II. 1 litre of polish will cover 12.25 meters squared. Find how many litres are needed to polish the entire sculpture. Give your answer correct to the nearest litre. Well, we're told that 1 litre of polish covers 12.25 meters squared of area. From the previous part of the question, we know that the complete area of the sculpture is 497.77 meters squared. So this is how much area that needs to be covered. To find how many litres of polish we need, we simply divide these two numbers. When we do this calculation, we get 40.6343. We were asked to give our answer correct to the nearest litre. So to get our final answer, we round this to 41 litres. Part III. A container of polish contains 5 litres and costs 110 Australian dollars. Find the number of containers of polish that must be purchased in order to polish the entire sculpture. And hence, find the cost of the polish in euros, given that 1 Australian dollar is equal to 0.68 euro. Give your answer correct to the nearest euro. From the previous part of the question, we know that we need 41 litres of polish. And we're told that each container contains 5 litres. So, how many containers will we need? Well, 8 containers would give us 5 times 8, which is 40 litres. This is not enough since we need 41 litres. 9 containers would give us 5 times 9, which is 45 litres of polish, and this is enough. So the minimum number of containers, which ensures we have enough polish, is 9 containers. Now, let's think about finding the cost of the polish in euros. We are told that 1 container costs 110 Australian dollars. We need 9 containers, and to find the price of this, all we have to do is multiply by 9. So 9 containers would cost 9 times 110, which is 990 Australian dollars. The question asked for the cost of polish in euros, not Australian dollars, so we'll have to do a conversion. We're told that 1 Australian dollar is 0.68 euros. To convert 990 Australian dollars to euros, we multiply both sides by 990. So we found that 990 Australian dollars is equal to 673.2 euros. We are asked to give our answer correct to the nearest euro. So to get our final answer, we round this to 673 euro. Part C. The diagram, not drawn to scale, shows the net of the outer surface of one of the cones of the sculpture. It is a sector of a circle of radius length 5.03 meters with arc length p meters and angle theta at the center, as shown below. Find p, the length of the arc of the sector. Give your answer correct to 2 decimal places. The key here is to get a good understanding of what this diagram really represents. We're told that it's the net of the outer surface of one of the cones. So let's have a think about the structure of one of the original cones. Since we're concerned with the outer surface, it will be helpful to imagine that the cone is hollow and is open on the bottom, sort of like an ice cream cone. Now, imagine we got a sharp knife and cut down a line from the tip of the cone down the side to the base. We could then flatten out the cone flat on the ground. Here, the tip of the cone corresponds to the centre of the circle, which I've coloured in blue. The cut we made with the knife corresponds to the radius of the circle, which I've coloured in green. And the circumference of the base of the cone corresponds to the arc length in the circle. I've coloured this in purple. The key takeaway from that illustration is that P, the arc length, corresponds to the circumference of the base of the original cone. We have a formula on page 8 of the formula book which allows us to find such a circumference. It says that a circle with radius r has circumference L given by L is equal to 2 pi r. We want the circumference of the base of the original cone. In part A, I, we were told that this radius is 2.25 meters. So to find our circumference, we sub in this radius to our formula. Our unit here is meters, so our final answer is that P is equal to 14.14 meters. Part II. Find theta, the angle at the centre of the sector. Show all your working out. Give your answer correct to the nearest degree. In the previous part of the question, we found that the arc length P was equal to 14.14 meters. So let's write this in. So, there's three things which are labelled in our sector: the angle, the radius, and the arc length. There is a formula on page 9 of the formula book which tells us how these quantities relate to each other. It says that the arc length, L, of a sector spanned by an angle of theta degrees in a circle of radius r is L is equal to 2 pi r times theta over 360. This equation will allow us to solve for the unknown angle theta. In our sector, the arc length L is equal to 14.14 meters. The radius r is 5.03 meters. Let's sub these values into our formula. From here, we can do some calculator work on the right hand side to simplify things a bit. 2 pi times 5.03 is 31.6044. To simplify things further, I'm going to eliminate the fraction on the right hand side. Theta over 360 means theta divided by 360. The inverse of division is multiplication, so to remove division by 360, I will multiply both sides by 360. So we found that 5090.4 is equal to 31.6044 times theta. To find theta, we'll need to remove this 31.6044 from the right-hand side. This number is being multiplied by our theta. The inverse of multiplication is division, so to remove this multiplication, I need to divide both sides by 31.6044. From here, it's a matter of doing some calculator work and some rounding. Rounded to the nearest degree, our final answer is that theta is equal to 161 degrees. Question 8. The diagram below shows the triangles CBA and CDE. The coordinates of C are 4.50. From the diagram, write down the coordinates of the points A, B, D, and E. In our diagram, the horizontal axis is labelled with X, and the vertical axis is labelled with Y. To find the coordinates of our points, we simply need to read off the values on these two axes. By convention, we always list the X coordinate first and the Y coordinate second. So let's start with point A. We have an X coordinate of 1 and a Y coordinate of -2. So A is equal to 1, -2. Looking at B, we have an X coordinate of 4 and a Y coordinate of 2. So B is equal to 4, 2. The coordinates of D and E can be found in a similar way to A and B. Part B. Show, using slopes, that the line segments AB and DE are parallel. The key to solving this question is the following fact. Lines are parallel if they have the same slope. So the strategy here will be to find the slope of both lines, show that they are the same, and hence show that the lines are parallel. To find our slopes, we'll have to use the slope of a line formula on page 18 of the formula book. It says that the slope m of the line passing through the points x1, y1 and x2, y2 is m is equal to y2 minus y1 over x2 minus x1. We are concerned with two different line segments, AB and DE. We'll need to find the slope of each. Let's start with AB. From the previous part of the question, we know that A is equal to 1, minus 2, and B is equal to 4, 2. To use our slope formula, we should label our first point, A, with x1, y1, and label our second point, B, with x2, y2. To find our slope, all we have to do is sub into the formula. So we found that the slope of AB is 4 over 3. Now for the slope of DE. From the previous part of the question, we know that D is equal to 6, minus 6, and E is equal to 15, 6. We'll label our first point, D, with x1, y1, and label our second point, E, with x2, y2. To find our slope, we simply need to sub these values into our slope formula. So we found that the slope of DE is 4 over 3. Remember, we know that lines are parallel if they have the same slope. We have shown that AB and DE both have a slope of 4 over 3. Since they have the same slope, we can conclude that they are parallel. Part C, I. Show that the area of the triangle CBA is 4 square units. This question concerns the area of a triangle in the context of coordinate geometry. There's a formula on page 18 of the formula book which will help us here. It says that the area of the triangle A between the origin 0, 0, P is equal to x1, y1, and Q is equal to x2, y2 is A is equal to 1/2 times the absolute value of x1, y2 minus x2, y1. We want the area of the triangle CBA. From the previous parts of the question, we know the coordinates of these points. A is equal to 1 minus 2. B is equal to 4, 2. And C is equal to 4.50. These 3 points define a triangle. Unfortunately, we won't be able to apply our formula directly. This is because it's very specific. It insists that one of the 3 points is the origin, 0, 0. To use our formula, we must translate our points so that one of them becomes the origin, 0, 0. Here, I will perform a translation to make A the origin. The first coordinate of A is 1. To make this a 0, I would need to subtract 1. The second coordinate of A is -2. To make this a 0, I would need to add 2. So the translation here is -1 to the first coordinate and +2 to the second coordinate. To ensure we're not changing the shape and area of the triangle, we need to apply the same translation to B and C. Now that we've translated one of our points to 0, 0, we're ready to use our formula. Here, we label the point 3, 4 as x1, y1, and the point 3.52 as x2, y2. So let's sub these values into our formula. The vertical bars denote an absolute value. This means that we must take the positive version of whatever's inside. So the absolute value of -8 is +8. A half times +8 is +4. Since this represents an area, our unit here is square units. We were asked to show that the area of our triangle CBA is 4 square units. And that's precisely what we've done. Part II. Find the length of the line segment AB. In other words, the distance from A to B. There's a formula on page 18 of the formula book which allows us to find the length of line segments. It says, given 2 points, P is equal to x1, y1, and Q is equal to x2, y2, the length of the line segment from P to Q is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We want the length of the line segment from A to B. The coordinates of these points were found earlier in the question. A is equal to 1 minus 2, and B is equal to 4, 2. To use our formula, we should label our first point, A, with x1, y1, and we should label our second point B with x2, y2. From here, it's a matter of subbing into our formula and doing some calculator work. Our final answer here is that the length of the line segment AB is 5 units. Part III. The triangle CDE is an enlargement of the triangle CBA. Given that the length of DE is 15 units, find the scale factor of the enlargement. Looking at our diagram, the triangle CDE and the triangle CBA have an identical shape. The only difference is that CDE is a bigger version. This is what the question is talking about when it says that CDE is an enlargement of CBA. We're asked to find the scale factor of the enlargement. Specifically, if we look at the corresponding sides in these two triangles, how many times larger will the side be in CDE? We can find our scale factor by comparing the longest side in each triangle. These are coloured in blue. AB is the longest side in the triangle CBA. In the previous part of the question, we found that the length of this side is 5 units. On the other hand, DE is the longest side in the triangle CDE. And we are told in the question that this side has a length of 15 units. So, if we compare the longest side in each triangle, we see that the side in CDE is 3 times larger. This means that our scale factor is 3. To summarise, the longest side in CDE is 3 times bigger than the longest side in CBA. So the scale factor is 3. Part IV. Use the scale factor to find the area of the triangle CDE. This area corresponds to the shaded region in our diagram. Well, from the previous part of the question, we know that CDE is an enlargement of CBA with a scale factor of 3. From C part I, we found that the area of CBA is 4 square units. So, we know the area of the triangle CBA. And we also know that CDE is just a scaled up version of this triangle. So if we scale up our area appropriately, we can find the area of CDE. The key observation is the following. area is measured in square units, so the area will get scaled up by the square of the scale factor. In equation form, this says that the area of CDE is equal to the area of CBA times the scale factor squared. Well, we know that the area of CBA is 4 and that the scale factor is 3. When we calculate 4 times 3 squared, we get an answer of 36. So our final answer here is that the area of CDE is 36 square units. Question 9. In June 2016, the UK held a referendum on its membership of the EU. Table 1 below summarises the results. The table contains the number of votes in several categories. The number of votes to leave the EU, to remain a member of the EU, the number of valid votes, and the total number of votes. Our first task is to write the number of invalid or blank votes into the table. The key observation here is that together, the valid votes and the invalid or blank votes will make up all the total votes. In other words, if we add together the valid votes and the invalid votes, we'll get the total votes. Another way to view this is that the invalid votes is equal to the total votes minus the valid votes. So let's do this calculation. So our final answer here is that there were 25,359 invalid or blank votes. Part II. Write the number who voted to leave the EU as a percentage of the valid votes. Give your answer correct to the nearest percent. Looking at our table, there were 17,410,742 votes to leave the EU. There were 33,551,983 valid votes. To find the proportion of people who voted to leave out of the valid votes, we divide these two numbers. We need to present our answer as a percentage. To convert this fraction to a percentage, we multiply by 100 and write in a percentage symbol. Doing the calculation here, we'll get an answer of 51.8918%. The question asks us to give our answer correct to the nearest percent. In other words, the nearest whole number. When we do this rounding, we get an answer of 52%. So our final answer is that 52% of the valid votes were votes to leave the EU. Part B. Table 2 shows the percentages of Remain and Leave voters in various age groups of those who voted in the referendum. Draw a suitable chart or charts to represent the data in Table 2. Taking a look at our table, we have the various age groups in the first column. The second and third columns give us the percentage of voters who voted to remain and leave in each of these age groups. For example, our first row here says that 73% of 18 to 24-year-olds voted to remain and 27% of 18 to 24-year-olds voted to leave. For our chart, we'll want to be able to compare the Remain percentage versus the Leave percentage for each of these age groups. A bar chart is suitable for this purpose. In this bar chart, I'll label the horizontal axis with the age groups. I'll label the vertical axis with the percentage of vote. The idea here is that for each age group, there's two percentages that we're concerned with. The percentage that voted to remain and the percentage that voted to leave. We can draw two bars side by side to represent this. Let's start with the 18 to 24 age group. Here, 73% voted to remain. So I'll draw in a bar with a height of 73%. 27% voted to leave. So I'll draw in another bar, this time with a height of 27%. The colour coding here is that I'm using orange for the Remain votes and purple for the Leave votes. So let's look at the next age group, 25 to 34. Here, 62% voted to remain. So in orange, I'll draw a bar with a height of 62%. 38% voted to leave. So we'll draw another bar in purple with a height of 38%. The rest of the age groups work in a very similar way. We look at the percentage of the Remain votes and the percentage of the Leave votes and draw one bar for each of them. We've now drawn in the bars for each of the age groups. So our bar chart is complete. Part II. Find the mean of the Remain values given in Table 2 and find the mean of the Leave values given in Table 2. Give your answers as percentages, correct to 2 decimal places. The key fact that we need to know to be able to solve this question is the following. To find the mean of a list of numbers, we add up all the values and then divide by the number of values. We need to find two means here, the mean of the remain values and the mean of the leave values. Let's start with the remain values. The values here are 73, 62, 52, 44, 43, and 40. To find the mean, we have to add all these values up and then divide by the number of values. Well, if we go to the calculator and add up the numbers, we'll get an answer of 314. If we count up the number of values on our list, we'll see that there is 6 numbers. To find our mean, we divide the sum, 314, by the number of values, 6. Rounded to 2 decimal places, our answer is 52.33. The values we were working with represented the percentage of people who voted to remain. So our unit here is a percentage. So our answer here is that the mean remain percentage is 52.33. Finding the mean of the leave values works in a very similar way. Here, our values are 27, 38, 48, 56, 57, and 60. If we add up all these numbers, we get an answer of 286. If we count up the number of values, we see that we have 6 values on our list. To find our mean, we divide the sum, 286, by the number of values, 6. So, rounded to 2 decimal places, the mean leave percentage is 47.67. Part III. Explain why the answers to Part BII do not accurately reflect the actual outcome of the referendum. In Part BII, we showed that across the age groups, the mean leave percentage was 47.67 and the mean remain percentage was 52.33. Here, the mean remain percentage was larger than the mean leave percentage. However, in Part AII, we showed that overall 52% of people voted to leave and hence 48% of people voted to remain. So overall, the leave percentage was larger than the remain percentage. The question is essentially asking us why these two things aren't in sync. In other words, why is it the case that when we look across age groups, the mean remain percentage is higher, but when we look at things overall, the leave percentage is higher? And the key observation here is that the number of voters in each of the age groups is important. Let's illustrate this with an example. The first age group in our table is 18 to 24. This interval spans 7 years. The last age group in the table is 65 plus. So this includes all the voters who are over 65 years old. There were probably voters who were 90 or even 100 years old. So I'd suspect that this interval spans over 30 years. So when we think about it, we would certainly expect that there will be a lot more people in the 65 plus age group than the 18 to 24 age group. This means that having a large percentage of the vote in the 65 plus age group is much more significant than having a large percentage of the vote in the 18 to 24 age group. When we calculated the mean percentages from our table, each age group carried equal weight. However, this is not representative of the actual votes. The age groups with a bigger number of voters should have been given a bigger weighting. So, in summary, the answer in BII does not accurately reflect the actual outcome because it does not account for the number of voters in each of the age groups. Part C. In the days following the UK referendum, a survey was conducted in Ireland on attitudes towards a British exit from the European Union. 1,200 people were surveyed. Find the margin of error of this survey. Write your answer as a percentage and give your answer correct to the nearest percent. We are asked to find the margin of error. The key to solving this question is the following fact. The margin of error is 1 over the square root of n, where n is the sample size. In this context, the sample size refers to the number of people who were surveyed. We were told that 1,200 people were surveyed. So our sample size, n, is equal to 1,200. We know that the margin of error is 1 divided by the square root of n. So here, that's 1 over the square root of 1,200. If we type this into our calculator, we get 0.0287. We are asked to write our answer as a percentage. To convert this to a percentage, we must multiply by 100 and put in a percentage symbol. If we do this, we get an answer of 2.87%. we were asked to give our answer correct to the nearest percent. So to finish off, we need to round this to the nearest whole number. This gives us a final answer of 3%. Part II. In the Irish survey, 578 of the 1,200 surveyed agreed that a UK exit would have a negative effect on the Irish economy. Use your answer in part C(I) above to create a 95% confidence interval for the proportion of the Irish population who agreed that a UK exit would have a negative effect on the Irish economy. Well, finding a 95% confidence interval boils down to the following two steps. Firstly, we calculate the sample proportion. And secondly, we subtract the margin of error to get the lower bound of the interval, and we add the margin of error to get the upper bound of the interval. Let's start with step 1. We are told that 578 of the 1,200 surveyed agreed that there would be a negative effect on the Irish economy. So here, our sample proportion is 578 over 1,200. If we type this into our calculator, we get 0.4817. The margin of error we found was in percentage form, so it will be useful to write this as a percentage also. To do this, we multiply by 100 and write in a percentage symbol. This gives us 48.17%. Now for step 2. From the previous part of the question, we know that the margin of error is 3%. To find the lower bound of our confidence interval, we subtract the margin of error from the sample proportion. Here, we get 48.17% minus 3%, which is 45.17%. To find the upper bound of the confidence interval, we add the margin of error to the sample proportion. Here, we get 48.17% plus 3%, which is 51.17%. So, we know the lower bound of the interval is 45.17%, and the upper bound is 51.17%. So our final answer is that the 95% confidence interval is 45.17% to 51.17%. Part III. After the survey, a political party claimed that 53% of the Irish population believed that the decision of the UK to leave the EU would have a negative effect on the Irish economy. Use your answer to part CII above to conduct a hypothesis test at the 5% level of significance to test the party's claim. Give your conclusion in the context of the question. In this question, the political party's claim involves the proportion of the Irish population who believe that the decision of the UK to leave the EU would have a negative effect on the Irish economy. Let's let P denote this proportion. Hypothesis testing involves a number of steps. The first step is to state the null hypothesis, H0, and the alternative hypothesis, H1. Typically, the null hypothesis corresponds to the assumption or the claim that is being made. In our question, the political party is claiming that 53% of the population believe there will be a negative effect on the Irish economy. In other words, they're claiming that our proportion, P, is equal to 53%. The alternative hypothesis represents the alternative options if the null hypothesis is not true. Here, the null says that P is equal to 53%. The alternative is that P is not equal to 53%. Step 2 is to create a 95% confidence interval for the data. And we've done this in the previous part of the question. We found that our 95% confidence interval is 45.17% to 51.17%. The third step is to look at the value for the null hypothesis, H0. If it is inside the confidence interval, then we fail to reject H0. On the other hand, if it's outside the confidence interval, then we reject H0 and move to H1. In our question, the null hypothesis assumes that P is equal to 53%. 53% is outside of our confidence interval, 45.17% to 51.17%. This means that we reject the null hypothesis H0 and move to the alternative hypothesis H1. The final step is to state your conclusion in the context of the question. In our question, the political party's claim corresponded to the null hypothesis, P is equal to 53%. We rejected the null hypothesis. So in the context of the question, we rejected the political party's claim that P is equal to 53% and moved to the opinion that P is not equal to 53%.